Welcome back to Models and Agents, episode 32. It's April 17th, 2026. The AI world never sleeps. Here's what you need to know today. Qwen3.6-35B-A3B brings sparse MoE vision language capabilities with only 3 billion active parameters and strong agentic coding performance. The Qwen team just open-sourced a model that changes the math on what you can run locally for multimodal agent work. This is the top story today because it delivers serious coding and vision performance while keeping inference costs remarkably low. The model has 35 billion total parameters but activates just 3 billion per forward pass thanks to a sparse mixture of experts architecture. That design gives it better coding performance than dense models in the 27 to 31 billion parameter range while using memory and compute much closer to smaller models. Early community testing shows it shines at Python data analysis, building web apps, and image recognition tasks. It does have a noticeable gap in non-English performance compared to its English and Chinese results, so keep that in mind for multilingual work. For developers, this means you can now run capable vision language agents on modest GPUs that previously demanded much larger dense models. If you have been building coding assistants, document understanding tools, or multimodal agents, this release is worth testing immediately. The open-source nature plus expected quantized versions should make integration into popular inference engines straightforward in the coming days. This release really strengthens the open-source ecosystem's ability to compete with closed multimodal models on practical agentic tasks. Now, on the model update side, the community is buzzing about ternary bonsai from Prism ML. They released a family of models at 8 billion, 4 billion, and 1.7 billion parameters using ternary weights of -1, 0, and +1. These models achieve roughly 9 times smaller memory footprint than FP16 equivalents while outperforming peers in their size class on standard benchmarks. The models come in FP16 safe tensors for immediate hugging face compatibility, and MLX 2-bit packed formats are already supported. People are especially excited about the roadmap toward 20 to 40 billion parameter ternary models that could challenge today's leading dense and MoE releases. For anyone doing edge or memory-constrained deployments, this feels like a practical step forward where every bit truly matters. Another notable release is Sage Sealer 2.6, introduced in 5 billion, 10 billion, and 27 billion sizes. The team added architectural modifications, inverse reasoning training to reduce cascading errors, and a native end-to-end vision encoder. These models emphasize strong mathematics, coding, and general intelligence alongside dedicated optimization for South Asian languages using a custom Devanagari tokenizer. What stands out is how they balance English reasoning capability with competitive performance in Nepali and Hindi without the usual multilingual degradation. The native multimodal design avoids the common adapter pitfalls that plague many other vision language efforts. Researchers also published a systematic comparison of linguistic adaptation across comparable-sized large language models. They tested Llama 3.1-8B, Mistral 7B-V0.1, and Qwen3.6-35B on Romanized Nepali using a 10,000 sample dataset under both zero-shot and QLoRa fine-tuned conditions. After fine-tuning with RS LoRa at rank 32, all models improved dramatically, with Qwen3.6-35B leading most structural metrics. Llama 3.1-8B showed the largest gains from its relatively weak zero-shot baseline. This work gives the first rigorous baseline for this under-resourced informal digital language and confirms there is still substantial headroom for low-resource adaptation pipelines. Shifting to agent and tool developments, a practitioner on the machine learning subreddit is looking for collaborators on a Chaos Monkey framework for multi-agent systems. After hitting production issues with multi-agent setups, they built a basic stress testing tool and want to mature it into a proper benchmarking and reliability suite. If you have shipped multi-agent systems at scale, this is a direct opportunity to contribute domain expertise and help establish better evaluation practices for production agent reliability. On the research side, the H-Technique RAG paper introduces a 2-stage hierarchical retrieval system for cyber threat intelligence. It first identifies MITRE attack tactics, then narrows to specific techniques, cutting the candidate search space by 77.5%. The approach adds tactic-aware re-ranking and hierarchy-constrained context organization. The result is a 3.8% F1 improvement over prior technique RAG while reducing inference latency by 62.4% and LLM API calls by 60%. Security teams working on automated cyber threat intelligence mapping should evaluate this for both accuracy gains and significant cost savings. In the practical and community space, one local Llama contributor posted a detailed head-to-head of Qwen 3.6 versus Gemma 4 models. The comparison covers text review, grammar checking and social sciences, light Python data analysis, and JavaScript TypeScript web work. Qwen leads on coding, STEM reasoning, and image recognition, while Gemma offers better non-English flexibility and more fuzzy creative thinking suited to humanities tasks. Both models still show some political and cultural biases, though improved from earlier versions, and the author even finds the occasional hallucination useful for staying mentally engaged. The post serves as a practical field guide for choosing between the two families based on your specific use case. Elsewhere, a machine learning engineer asked the community whether to buy an M5 series Mac with MLX or build a custom RTX 5090 machine. Their workload breaks down to 70% fine-tuning large pre-trained models and 30% training from scratch, mostly image and video with occasional large language models. The discussion delivers useful real-world insights on VRAM needs versus Apple's improving MLX ecosystem for on-device and fine-tuning work. It is a timely look at the budget, memory, and framework maturity trade-offs many practitioners face right now. Researchers also released MemGround, a long-term memory evaluation kit for large language models and gamified scenarios. It uses a 3-tier hierarchical benchmark covering surface state, temporal associative, and reasoning-based memory, inside rich interactive environments instead of static retrieval tests. The suite adds multi-dimensional metrics like memory fragments unlocked and exploration trajectory diagrams. Current state-of-the-art models and memory agents still struggle with dynamic tracking and long-term evidence reasoning according to these tests. Teams building long-context agents or memory-augmented systems now have a much more realistic evaluation suite to measure real progress. Okay, let's pop the hood on these post-transformer adapters for logic correction that the community has been discussing. Everyone talks about uncensoring or fixing aligned models as if you simply need better prompts or bigger models. In practice, the suppression of factual log probabilities on sensitive topics often lives in the final layers, even when the knowledge is clearly present in hidden states. The elegant engineering fix is a tiny post-transformer adapter of roughly 786,000 parameters, which is only 0.02% of a 4 billion to 14 billion parameter base model. It reads frozen hidden states and learns a corrective mapping before the final language model head. This restores proper probability rankings without retraining the entire model. Both gated SwigLU and simple linear bottleneck versions perform comparably, so the exact architecture seems less critical than the intervention point itself. Applying the adapter at every token position during generation destroys coherence. Restricting it to the current prediction position, meaning last token only, yields fluent and less censored text. A logit space adapter after token projection fails entirely, confirming that hidden state intervention is the correct level of abstraction. Training uses anchored examples to prevent regression on general knowledge. The adapter delivers perfect memorization of training facts and 11 to 39% generalization to held-out items across different scales. The quality gain is most pronounced on smaller models. Above roughly 70 billion parameters, the hidden state misalignment appears to shrink, and the adapter's relative value drops. So when should you actually reach for this versus the alternative? Use post-transformer adapters when you need surgical behavior correction on a frozen base model and can afford a few 100,000 extra parameters. They are dramatically cheaper than full fine-tuning or preference optimization for targeted logit repair. The gotcha that still bites teams is applying the adapter at the wrong position in the generation loop. Always validate last position only behavior first. If you have not tried Qwen3.6-35B-A3B on a coding or multimodal agent task yet, this week is the perfect time. Its 3 billion active parameters and agentic training make it surprisingly capable on modest hardware. Load one of the ternary bonsai models, especially the 8 billion version, in MLX or Hugging Face to test how 1.58-bit weights feel for your specific workload. Experiment with the H technique RAG code for mapping cyber threat intelligence reports to MIT, REATT, and CK. The latency and API cost reductions are immediately measurable in practice. Run the MemGround benchmark scenarios against your current long context or memory augmented agent to see where dynamic tracking actually breaks. Compare Qwen3 to 8B versus Llama 3.1 to 8B on romanized Nepali or another low resource script after a quick QLORA pass. The adaptation headroom differences are striking and instructive. On the horizon, keep an eye on expected follow-up releases of larger ternary models in the 20 to 40 billion scale from PrismML. They could reshape local LLM viability in a big way. Before we go, tomorrow keep an eye on further community momentum around Chaos Monkey frameworks for multi-agent reliability testing. That's models and agents for today. If you found this useful, share it with someone who's trying to keep up with all these changes, and subscribe so you don't miss tomorrow's update. The AI world moves fast. We'll help you keep up. See you tomorrow. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content, and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.